Imagine a grand cosmic show, coordinated by an infinite number of moons, planets, and stars, all performing together in flawless synchrony. Yet, amidst this celestial harmony, one section has mystified astronomers for ages: exoplanets. By definition, non-solar planets are those outside our solar system, nestled deep within the vast expanse of the universe. You can see the entire Milky Way galaxy, but you might be surprised to learn that one of the numerous cosmic entities that exist, Earth-like exoplanets, are so remarkably comparable, yet mysterious, that they might actually be Earth's twin. As we enter the enthralling world of Proxima B, which is just 4.2 light-years away, decades from now, the James Webb Space Telescope is revolutionizing our ability to investigate and comprehend these mysteries of the universe. For a moment, imagine your mind drifting through the enormous astronomical domain of our galaxy, the Milky Way, which houses over 1 billion exoplanets. That's 1 followed by 15 zeros. To grasp the magnitude, if each of these exoplanets were the size of a grain of sand, it would not only fill the Grand Canyon but also supply sufficient material to construct an entirely new geological wonder. How far is the Grand Canyon? 2.0 miles in surprising length, about 20% of the Earth's surface. There have been many of these celestial bodies identified as Earth-like in terms of their atmospheric and geological characteristics, which indicate that there is a chance, about 1 in 5, of discovering a planet that mirrors our own. And the story doesn't end there. Alongside these planets, we could find an additional 4 billion moons or rocky satellites that resemble our own moon, engaged in a dance of gravitation with their parent planets. Should we ponder the potential discovery of another body in space capable of supporting life, the cosmos provides numerous opportunities. It's the canvas of the vastness of the universe. It's time to talk about the master artist, ready to paint its fine details, the James Webb Space Telescope. This celestial Sherlock Holmes, equipped with its substituting telescopic lens for a magnifying glass, surpasses even the most sophisticated optics. We're not simply discussing any lens. Its 6.5-meter primary mirror is 2.7 times larger than Hubble's. Consider the precision it provides, recognizing the tiniest star flicker a distance of billions of light-years, and then studying the orbiting planets around them. The James Webb Space Telescope is revolutionary, not just because of its incredible observational capacity, but due to its cutting-edge technologies like sensors that can see in the dark and spectrographs. These tools are capable of a lot more than just observing. They can evaluate and select the various light signatures that were emitted or reflected by celestial bodies, unraveling their atmospheric makeup, density, mass, and even their composition. Acting like a cosmic detective, it can ascertain whether a planet harbors water, organic compounds, or even oxygen. The James Webb Space Telescope is elevated from a mere observer to an analytical genius, not just surpassing Hubble but making a monumental leap forward. If Hubble's discovery stunned you, brace yourself for a variety of revelations from the stars as we broaden our view of the vast cosmos. Let's focus on a particular star in this celestial performance, Proxima B. Because its discovery in 2016 has intrigued scientists, Proxima B appears like a Shakespearean character, full of contradictions and complexity, captivating astronomers and biologists alike. Why all the excitement? For one, Proxima B is nearly part of our cosmic neighborhood, located just 4.2 light-years from Earth. To help put this into perspective, if you could exceed the speed of light, you'd reach it in just over 4 years, about the same time it takes for a presidential term to pass or a favorite TV show to fade from popularity. But why does its proximity matter so much? In a universe spanning over 93 billion light-years, finding a planet that is so close and looks so promising for research and science is like finding a diamond in a pile of stones as vast as Mount Everest. This planet may contain the keys to understanding life itself. Proxima B is not just intriguing for its proximity to Earth, but also because it might not just be Earth-like, it might be an Earth 2.0. Positioned comfortably in what astronomers call the habitable zone of its parent star, Proxima B enjoys conditions that are neither too hot nor too cold, making it just the right environment for liquid water to exist. Imagine waterfalls, winding rivers, vast lakes, and possibly oceans, profound and mysterious as the Mariana Trench. However, before you begin planning your vacation on Proxima B, it's important to consider some peculiarities. For example, a single day on this captivating exoplanet lasts a mind-boggling 11 Earth days. Envision sunrises that not only signal the beginning of a new day but gradually unfold, resisting the transition to sunsets at midday that stretch on, creating long golden hours that photographers aspire to. Even though it might sound great, after these long days, the prolonged cycles of light and darkness could have significant effects on its climate and habitability. How would humans adapt to such cycles? Would we need to eat more often, perhaps 3 or 4 times a day? How would our sleeping patterns change in one day? Life as we know it would feel both eerily familiar and bizarrely different. One might be curious about how accurate and reliable data about a world we've never visited can be. The James Webb Space Telescope uses its full array of capabilities, functioning like a cosmic Swiss Army knife. More than just a telescope, it's a multifaceted research facility in the vastness of space. Thanks to its cutting-edge technology, astronomers can not only observe these distant planets but also use a range of analytical instruments to examine them. Using advanced spectrographs, the Webb telescope can examine the reflected and emitted light by these far-off planets. Each element or compound in a planet's atmosphere absorbs or emits light at a unique wavelength, and by analyzing these wavelengths, scientists can remotely biopsy these planets. This allows them to assess atmospheric pressure and density, and even detect essential compounds such as water, organic carbon molecules, and oxygen. It's not just astronomy, it's space forensics. Rather than passively waiting for clues, we actively search for them, examining the molecules and atoms that comprise these distant worlds. The Webb telescope is not just a passive observer in the sky, it is an extremely specialized lab analyst and cosmic detective all in one. It allows us to turn our speculations and theories regarding alien worlds into tangible evidence, or disproves them, by enhancing our comprehension of the universe. It's transforming our awareness of what may exist beyond. Just when you thought you had discovered all the extraordinary secrets of the cosmos, the story takes an unexpected turn. As with any gripping science fiction tale, researchers who make use of the James Webb Space Telescope detected something extraordinary emanating from Proxima B, a signal so unusual that it rippled through academic and social media circles, being labeled as a potential technosignature. It was an electromagnetic emission so complex and designed that it could point to the existence of a sophisticated civilization. As the scientific community wrestles with the implications of the mysterious signal, the search for answers intensifies. With no definitive explanation, the question looms larger: could this be the first whisper of an advanced civilization just beyond our reach? The excitement over Proxima B grows, fueled not only by the signal but by the tantalizing prospect of a second Earth, teeming with potential for discovery. But the challenge remains. Proxima B's distant orbit, its peculiar day-night cycle, and its extreme distance still pose significant hurdles for exploration. The technology required to reach this distant exoplanet, even at the speed of light, would take decades, and current spacecraft are far from capable of such a journey. For now, we are limited to observing through the lens of our most powerful telescopes, hoping for more clues that will bring us closer to answering the grand question: is Earth truly unique in the universe? As we continue to analyze the data sent back by the James Webb Space Telescope, scientists are beginning to consider more bold hypotheses. Some wonder if Proxima B could harbor not just the building blocks of life but perhaps something more: signs of intelligence, technology, or artifacts left behind by a long-lost civilization. Could Proxima B be the key to unlocking an entirely new chapter in human history? A chapter that transcends the boundaries of our own planet and reveals that we are not as alone in the universe as we once believed? In the meantime, the search for more exoplanets continues. New discoveries are made almost every day, expanding our understanding of the cosmos and the potential for life beyond our solar system. Astronomers now know of thousands of exoplanets, each with its own unique characteristics and mysteries. Some are far too hot or cold to support life, others are shrouded in gas, and some are located in the so-called habitable zone, where conditions might be just right for liquid water to exist. The possibilities are endless, and with every new discovery, humanity's imagination stretches a little farther. The dream of exploring the stars, of one day setting foot on planets like Proxima B, remains alive. As technology advances and our understanding of the universe deepens, what once seemed impossible is becoming increasingly plausible. Human ingenuity, combined with the tools provided by the James Webb Space Telescope and other cutting-edge instruments, might one day allow us to answer questions that have plagued us for centuries. Is there life elsewhere in the universe? Are we alone, or do we share this vast expanse with other intelligent beings? As we continue to reach for the stars, the mysteries of the cosmos unfold before us, like a cosmic treasure map leading us toward the unknown. Whether we will ever be able to travel to distant worlds like Proxima B remains uncertain, but the pursuit of knowledge and discovery will undoubtedly continue to shape the future of humanity for generations to come. The story of the universe is still being written, and we are just beginning to turn its pages. Of a much broader cosmic narrative, in addition to being more complex than we can fathom, just when you think that a new mystery has been solved, a chapter unfolds. It's no longer just astronomers leading the charge, Harvard researchers are now driving a paradigm change in the pursuit of extraterrestrial life, life that they aren't happy with just analyzing signals and phenomena. They're extending the boundaries through transformation, a one-of-a-kind James Webb Space Telescope, a cosmic night vision device. Their objective is to search for artificial light sources on distant worlds in both dark and illuminated regions. This could have profound implications, such as detecting terrestrial-style cities glowing in the dark, as one might imagine bioluminescent species seeing glowing poles that come out of a world that has the potential to house an advanced civilization, shining its lights into the immense cosmic ocean. As we proceed exploring the vastness of space and the endless possibilities it holds, the implications of these discoveries are far-reaching. The idea that we might not be alone in the universe has captivated humanity for centuries, and with each new advancement in technology, our chances of obtaining the truth expand exponentially. The James Webb Space Telescope represents a significant advancement in our search for knowledge, giving us the tools to explore planets and stars in the distance, uncovering and deciphering their secrets, and opening new realms of possibility. With every passing day, we inch closer to comprehending the nature of the universe. Whether we find evidence of life in the cosmos, discover the mysteries of far-off planets, or look for electronic signatures that point to intelligent civilizations, the journey is only beginning. The cosmos is packed with unanswered questions, and the potential for new discoveries is endless. The work that is being done by astronomers and researchers today will pave the way for future generations to unlock the secrets of the universe. In the upcoming years, we might see breakthroughs that will redefine our understanding of life and the universe. What once seemed like science fiction may become reality as our tools become more sophisticated and our knowledge increases. The options are endless, and the adventure of exploring the cosmos is one that will continue to captivate and inspire us for generations to come. The exploration of exoplanets, and specifically the search for Earth-like worlds like Proxima B, is a reflection of our deep curiosity and our unyielding desire to comprehend our position in the universe. With every new discovery, we come closer to answering some of the most profound questions humanity has ever asked. Are we alone? What lies beyond our planet? And what other forms of life could exist in space's vast expanse? As we continue to look to the heavens and the stars, investigating the farthest reaches of space, there is still hope for cosmic discovery. Bright, the James Webb Space Telescope is just one of many tools that will help us uncover the mystery of the universe, and its discoveries will shape the future of science and astronomy for many years to come. As we continue to explore the cosmos, the universe has this one certainty: much more to reveal, and we are only beginning to scratch the surface. As the search for life beyond Earth continues, each new discovery contributes to the complete grand cosmic puzzle. The idea that planets like Proxima may contain the very essence of who we are is tested by life itself, an existence that inspires profound philosophical questions. What does it mean for humanity if we find a twin of our world? How would this impact our understanding of life, evolution, and our place in the universe? It's not hard to imagine that finding a planet like this could lead to a radical shift in science, politics, and even culture. Would the confirmation of another Earth-like world lead to unity around the world, or create new divisions in the pursuit of exploration and resources? These are only a few examples of the many questions that keep coming up as our exploration of the cosmos intensifies. But the process of learning about life, or even the possibility of living far away on exoplanets like Proxima B, is not just about locating a different version of Earth. It's about unlocking the many mysteries that the universe holds, many of which are beyond our comprehension. We're venturing into previously unknown regions, pushing the boundaries of what we know, and with each discovery, we reshape our understanding of the cosmos. The James Webb Space Telescope and its unprecedented power go beyond revealing brand new stars and planets. It's transforming the very way we study the universe. It enables researchers to turn questions that were previously confined to speculation into grounded, testable theories. It's a new period of space exploration in which knowledge is no longer limited to what we can see with our eyes, but to what we can comprehend using our technology. The advanced sensors on the James Webb Space Telescope make it a game-changer in our ability to use infrared light to search for alien life. The technology can peer through cosmic dust and gas that once obscured our view. It is able to detect even the tiniest glimmers of light from distant stars and planets, looking into the chemical signatures in their environments for the building blocks of life. What's even more remarkable is the telescope's ability to examine the light from distant exoplanets in greater detail than ever before. Each spectrum of light that a planet's reflection or emission can reveal provides a wealth of information about its composition, from the presence of water vapor to the possibility of gases like methane or oxygen, which are important indicators of biological activity. The telescope opens up a whole new frontier in the search for extraterrestrial life. With each discovery, we edge closer to answering the most fundamental questions about life, existence, and our place in the vastness of the universe. The potential implications of these findings extend far beyond the realms of science. If we were to confirm the existence of life elsewhere, particularly intelligent life, it could redefine everything we know about humanity's role in the cosmos. We would no longer be isolated in our understanding, but part of a larger, interconnected universe that may hold untold secrets and mysteries waiting to be uncovered. As we venture deeper into this exploration, new technologies and advancements in space research will continue to push the limits of our knowledge. The James Webb Space Telescope is just the beginning. Future instruments and missions will only expand our ability to observe and analyze the universe in ways we once thought impossible. In the years to come, missions to distant exoplanets, moons, and even the outer reaches of our own solar system will allow us to gather even more data, offering fresh perspectives on questions we haven't even thought to ask yet. These discoveries will not only shape the future of science but will also influence global culture, philosophy, and even policy. The very fabric of society may be transformed as our understanding of life and the universe evolves. Just as the discovery of the New World had profound effects on civilization, so too could the discovery of extraterrestrial life, especially if that life is found to be more complex, intelligent, or advanced than our own. But as we reach further into space, we must also consider the ethical and societal implications of our discoveries. How will we approach the discovery of alien life? What responsibilities will we have as stewards of our planet and potential ambassadors to other civilizations? These questions are just as important as the scientific ones, and they will require careful thought and collaboration from scientists, ethicists, policymakers, and the global community. In the end, the exploration of the cosmos is not just about finding answers, it's about expanding the boundaries of human knowledge and understanding. It's about asking the right questions and pushing the limits of what we think is possible. Each step we take toward understanding the universe brings us closer to understanding ourselves, our origins, and our potential future in the cosmos. As we continue to look to the stars, we can be certain that the journey of discovery will never end. There will always be new horizons to explore, new mysteries to solve, and new possibilities to imagine. And through it all, the spirit of curiosity, exploration, and discovery will continue to guide humanity in its quest to unlock the secrets of the universe.